In this section, we are going to practice some of the most common column operations that data engineers use every day. Before we start working with columns, let's quickly recreate our Spark data frame. Here, we use spark.read.csv and point Spark to the car's CSV file. Now we run the cell, and the data frame is ready for the next column operations. Let's start with selecting a single column. In PySpark, there are different ways to select a column from a data frame. The first method is using dot notation. Here, we type df.char. Spark returns a column object, not the actual data yet. This is important to understand. A column object represents a column expression that Spark can use later inside transformations. Now we try to use that column inside a select. We write df.select, passing df.char, and then we run show to preview the result. In this dataset, the column is named char with a capital C. So, when we use dot notation with the wrong case, Spark cannot resolve it correctly. That is why, as a best practice, we should be careful with dot notation. Now, let's use the second method. This time, we select the column by passing the column name as a string. We write df.select, then char inside quotes, and run show. Now it works. Spark displays only the char column, and we can see the first few char names in the output. This method is simple and very common. It is also easier to read when we are selecting columns by name. Next, we look at another way to select the same column. We can also use the call function from PySpark SQL functions. This is a very useful approach because call creates a column expression explicitly. It is especially helpful when we are building transformations, filters, derived columns, or more complex logic. So the key idea is this. Use string column names for simple selections. Use call when you need more control inside transformations. And be careful with dot notation because it can break when column names are case-sensitive or conflict with existing data frame attributes. Now let's move to selecting multiple columns. The idea is almost the same, but instead of selecting one field, we select two or more fields at the same time. First, we select multiple columns using dot notation. We pass df.char and df.cylinders into select. Spark returns only those two columns. This is useful, but again, dot notation is not always the safest option. Next, we select multiple columns using string names. We pass char and cylinders as strings into df.select. This is usually cleaner and easier to maintain when the column names are simple. Now we use the call function again. We import call from PySpark SQL functions. Then we pass call char and call cylinders into select. This gives us the same output, but now we are using explicit column expressions. This style is very common in real PySpark code because it works well with transformations and makes the logic more flexible. Perfect. Now we know how to select one column and multiple columns using different PySpark styles. Next, let's add new columns. This is one of the most common operations in data engineering. We use new columns when we need flags, constants, calculations, cleaned values, derived fields, or business logic. In this first case, we add one new column. We import lit from PySpark SQL functions. The lit function creates a literal value. That means it adds the same fixed value to every row. Here, we use withColumn to create a new column called first column. Then we assign the literal value 1. When we run the cell, Spark adds the new column at the end of the data frame. Now we display the first rows and confirm that first column exists, and every row contains the value 1. This is useful when we need to add a static value, a flag, a source identifier, or a default value. Now let's add multiple columns. We use withColumn again, but this time we chain it. First, we add second column with the value 2. Then we add third column with the text third column. When we run the cell, Spark creates both columns and adds them to the data frame. Now the output includes first column, second column, and third column. This is a very common pattern in PySpark. We can chain transformations step by step, and each transformation returns a new data frame. Now let's create a derived column from existing columns. For this case, we want to combine values from the char column and the model column into one new column. We import concat and call from PySpark SQL functions. Then we use withColumn to create a new column called char model. Inside that new column, we use concat. We pass the char column, then a literal space, and then the model column. This creates a new string by joining the char name and the model year. When we display the data frame, we can see the new char model column at the end. For example, it combines the char name with the model value, giving us a new readable field. This is very useful in real projects when we need to build business keys, labels, descriptions, or combined fields from multiple columns. Now let's move to renaming columns. To rename columns in PySpark, we use withColumnRenamed. This function receives two values. First, the current column name. Second, the new column name. Here, we start by renaming first column to new column 1. Then we rename second column to new column 2. And finally, we rename third column to new column 3. We chain these rename operations together, and then we display the data frame. Now the output shows the updated column names. The original columns are replaced with clearer names. This is useful when we need to clean column names, standardize naming conventions, or make our data frame easier to understand before saving it into a table. Now let's continue with another common data frame operation, grouping data. In PySpark, we use groupBy when we want to summarize records by one or more columns. First, we group the data frame by the origin column. Then we apply count, and finally we use show to display the result. When we run the cell, Spark counts how many cars belong to each origin. We can see values like US, Japan, and Europe, each with its total count. This is useful when we want to quickly understand distributions in the data. Now let's group by multiple columns. This time, we group by origin and model together. Then we apply count again and show the first results. With this approach, Spark creates groups using the combination of both columns. So instead of counting only by origin, now we can count by origin and model year together. This is very common in real data engineering work when we need summaries by category, region, date, product, or any business dimension. Now let's move to removing columns. Before dropping anything, we check the current list of columns using df.columns. Here we can still see the original columns plus the extra columns we created earlier, like new column 1, new column 2, new column 3, and car model. To remove a column, we use the drop function. First, we drop new column 1. Then, we check df.columns again to confirm that the column is no longer part of the data frame. Now we repeat the same idea with the other temporary columns. We drop new column 2, and then we drop new column 3. Each time we use drop, Spark returns a new data frame without that column. This is important because Spark data frames are immutable. That means Spark does not modify the original data frame directly. Instead, it creates a new version of the data frame with the requested changes. Finally, we use display_df to preview the clean data frame in Databricks. Now we can see the table again, but without the temporary columns we removed. So, quick summary. Use select when you need specific columns. Use call when you need explicit column expressions. Use withColumn when you need to add or transform columns. Use lit when you need constant values. Use concat when you need to combine columns. Use withColumnRenamed when you need cleaner column names. Use groupBy when you need aggregations or summaries. Use count to calculate the number of records per group. And use drop when you want to remove columns that are no longer needed. These are basic operations, but they are extremely important for real data engineering work in PySpark and Databricks.